Hello, everyone, and welcome. It is Wednesday. It is May. It is the third Wednesday of May, which means Meteorite or Meteor-wrong time. The crew has assembled. The Patreons have sent in their videos. We are good to go. I don't know why I'm doing this in the sports. I figured it's Stanley Cup playoffs, might as well. We have two submissions today, and I've already asked the crew to help me out because they are more experienced. There's so many decades of experience in this gallery on this screen right here. It's overwhelming. Let's look at our very first submission from Samuel. And let me see here. Oh, we have a pretty long video from Samuel, and we're just going to let it play because I think it's narrated pretty well. This was found in Nicaragua, so this is really cool because we've had a lot of we've had a good amount of international supporters on our Patreon and a rock counter sending in stones from around the world. This is exciting for me. So this was found on a beach. Probably not the best place to search for meteorites, but they land everywhere. And we have far from the water, and it weighs about 40 grams. We ask people always to tell us what they are seeing in their sample so we can look for those same things and also try to educate either, yes, that is fusion crust, or no, it isn't fusion crust. Here's what fusion crust would look like. Here's why that can't be flow lines. Here's where flow lines would be, those type of things. So he mentions a fusion core, not really sure what that is, maybe language thing, so fusion crust, and it may be a lunar. So very, very bold claims of a fusion crusted lunar found on the beach, to be quite honest with you, but I'm rooting for you, Samuel. Let's get into your video.
Hi guys, my name is Samuel Montenegro, and this is a rock I believe that could possibly be lunar meteorite. I live in northern Nicaragua. My father witnessed it fall on April 3rd. So it was 8 a.m. He was eating breakfast. He was at the beach, and about 5 meters from him, this fell vertically with force enough that it couldn't be attributed to somebody throwing it or to, let's say, a slingshot. It says it surprised him that it came through the trees vertically. I've never found, like I said, I've never really knew what meteorites are. I've been trying to study. I personally thought they were like jagged and like in the movies. So when my dad showed it to me, I'm like, that's not a meteorite, that's just a rock. So I took it, not thinking much of it, but as I've been reading, I find some similarities to some lunar meteorites. I know they're extremely rare and it's most likely not, but I wanted to hear you guys' opinions. It weighs 40 grams. It is slightly magnetic. So here is a magnet. You can see it's fairly strong. While it doesn't stick to the rock, it moves it just a bit. I don't know if you can pick it up on camera, but it moves it a little bit. But it does not stick to it. So the biggest issue, I guess, would be the fusion core. And I do believe it has it. Let me see if I can steady my hand. Sorry if it's a little bit shaky. I believe that's where it happens to be. There's also a couple of places where it seems to be a little bit of scorch marks. Oh, I filed a part of it down. I'll get to that part pretty soon. Let's About the other classifications, I'm not entirely sure. Like if it's a Rexia, and when it landed, my father said it was warm to the touch. Can't see. I'm gonna move a little bit faster right now. Okay, here we go. This is where I filed it down. See if I can get a little bit closer. I'm gonna put it down. I feel like my hands, I'm a little bit shaky. Sorry about the gloves. Maybe I should do it again without. I thought it might help with the contrast.
We're getting a good look at this first. I mean, probably one of the best. I see everyone nodding. We're getting one of the best looks at a rock we've had in a while. Good job, man. When Sue told me it was a 5-minute video, I was like, oh God, please no. That was great. The well lit, well narrated. You told us what you thought. You gave us a story about it. Really, everything like was on track and on point as far as staying on topics, telling us things that we need to hear and see. Not, I think, like Sue always says, not like what you had for breakfast that day. We don't need to hear that. We need to hear where he was, what happened when it came through. So yeah, I think great photos, good video. This is supposed to be an in situ photo right here, but it looks more like just a nice place to take a walk. I don't really see the stone on the ground as it landed. That's kind of what an in situ photo is supposed to be more like. And I'm giving everyone time to raise their hands as I chatter. So normally that's what an in situ picture is it laying in the ground where it laid, either undisturbed or put back after you realize what it was. So I'm going to turn it over to the crew. We have David and Bruce with their hand up. So David, why don't you go first?
Yeah, it's a really well shot rock. It was great, and I'm not sure what that rock is, but there's one thing that I could say for sure is it really doesn't look like a fresh fall. There looks like there's on that part something that kind of looks like caliche. It looks like it's been in the ground for a long time. There's no real fusion crust on that. I saw dark stuff on there, but fresh fusion crust is quite unmistakable. Even some that are, have some of it that's got knocked off a bit. There should be some really fresh fusion crust on that. But the inside is kind of unusual. I can't say what rock that would be, but it doesn't look like a fresh fall.
Okay, let's call that the black and white answer. You're talking about the black fusion crust and the white stuff on there.
Yes.
It looks to you and I both that white is an additive over time, a terrestrial additive over time.
Yeah.
I tend to agree with you that we're not seeing fresh fusion crust, but I do have an opinion as what we're seeing in place of that fusion crust. But I'm going to go around the horn and see what the crew has to say. Bruce?
Welcome, Daniel, by the way.
Oh, Daniel Sheikh, welcome to the conversation. Bruce?
Yeah, I have a similar concern about the white part there. But in looking at the other, as he was turning it around, the darkness of the exterior doesn't match the interior. Like right there, you can see, it looks like an aged fusion crust, not a fresh one. But, it looks like there's a little bit. It's hard to tell how thick it is in the video and even in the photos. It looks very granular, very possibly very chondritic. So I'd say this is a very strong possibility to being a meteorite.
I like the fact that we actually have some internal structure in this one. I have to agree that we've seen a lot of them that really have no internal structure. What I'm seeing, I'm gonna comment on what I'm seeing on the outside of it, and this is a good freeze frame here where we can kind of see that terrestrial additive, weathering additive that we refer to as caliche maybe, and that caliche is just generic form. We're calling it the Kleenex of terrestrial additives, if you will. This doesn't appear to be fusion crust to me. This dividing line does not, it doesn't look like fusion crust to me. What it looks like to me is a weathering line. So I want to know if anyone has an opinion on that as well, but also about the internal structure. But before we do any of that, I see my wife has her hand up and she gets first of everything.
Oh gosh, mine was just it's not necessarily about the rock. It was a clarification on one of the photos that Samuel had provided. I always ask for in situ pictures, and I noticed in his notes he called this one a situ picture. So I think he's just showing us the general area of where it landed, but not the rock in the ground. I don't know if he just didn't understand
that's exactly,
yeah.
That's exactly what he showed us. So perfect, right
Okay.
on. Yeah, that matches then. I see Allison with her hand up on if you have a comment about that. Then we have Daniel Sheikh, so he's gonna trump you, Pat. Sorry. Allison?
Yeah, thanks. Good submission. I do agree. Thanks, Topher, for saying that. I think I see like almost a dual lithology right there. Like the black part and the white part are two different textures smushed into one stone. It is, like Bruce said, kind of granular. And I almost think I see like some spaces between the grains, like some little like air pockets. And I'm not saying that they're gas bubbles. I think I see some spaces in between those grains, which we don't usually see in meteorites. I can assure you, Samuel, that I don't think this is a lunar meteorite. And I'm not particularly great at identifying lunar meteorites, but lunar doesn't usually attract the magnet, and your stone did definitely respond to that magnet. So
But
I think we can scratch lunar off safely.
I'm gonna interrupt you, Allison, because we're gonna go back to what would Allison say? We're gonna get those lights.
That it could possibly be a chondrite, but I just am not real sure that that's a chondrite either. So
you always ask what type of meteorite could it be, and if it has chondrules, then it can't be an achondrite and it can't be a lunar. So we're either happy to see chondrules or we're bummed to see chondrules, because it can't have chondrules and be an achondrite. So thank you for that. I appreciate that. Daniel Sheikh, if you could add to the conversation, we'd appreciate it.
Hey, how's everyone going? Hi, Topher. Hi, everyone. Thanks. Sorry I came on a little late. I got the timing wrong. So the first thing I noticed with this stone was that when they showed the cut of the face, it almost looked like the texture sort of resembled something like a porphyritic basalt, just on the way it looked. I saw grains, they looked like they were entrained in some kind of melt. Allison mentioned something about potentially being holes in the sample. There may be vesicles in there. It doesn't have a typical chondritic texture that I'd normally expect unless it was cut sort of perpendicular to maybe if you had one large chondrule and you're seeing the inside and you're just seeing sort of the igneous texture. But from the way that I'm seeing the stone and how it looks weathered, it does sort of look like something you'd expect to see of a weathered, terrestrial porphyritic basalt. And from the way those minerals look, they look almost like maybe pyroxenes. They could also be, I mean, I know when you weather feldspar, it could get sort of that tan color, but normally they don't really look that color. So I think it's some mafic mineral. So I don't know. I mean, from just seeing just that one image and looking at that, my immediate thought was some kind of terrestrial porphyritic basalt, but I could be entirely wrong. So.
Well, I appreciate and we put a little bit more value on your opinion than mine, but when you look at this one and you're seeing, hopefully I have a good freeze frame here for what you were talking about, this texture here. Chondrules in the perfect world, are round. These look like angular clasts. Um, is that where you're getting the porphyritic from?
Yeah, in the terminology of igneous rocks on Earth, when we deal with things like extrusive, like rocks that form from lava flows, like basalt, the term porphyritic means that you have essentially two different grain size fractions. You have larger grains, and then you have a bunch of smaller grains. So that means that those what you refer to as clasts, they could just represent large mineral grains that grew, and then they were in sort of a lava flow on the surface that cooled quickly, so you have two different grains. The other alternative is that if these were clasts, and given how some of them sort of look angular, subangular, maybe subrounded, then the other thing this could be, if it was a meteorite, is it could be some kind of breccia of some sorts, like maybe a melt breccia, where you have just clasts sort of floating around in a melt-rich matrix. That would probably be the best guess for what I'd say this could be if it was a meteorite, because it doesn't exactly have a typical chondritic texture. Now, there are, of course, chondrites that are brecciated and that don't have chondrules in those brecciated chondrites just because of, how they formed. But just overall, it doesn't give me that sort of impression from the appearance. So I'd probably say if it was a meteorite, it would be some kind of melt breccia. That would be my 2 cents,
Well,
probably.
I appreciate that. I'm gonna take the next logical questions, for at least for me and every rock counter that seems to deal with me. Okay, awesome. We're hearing probably the most positive feedback we hear on a submission. We're not seeing heads shaking and no, I don't like this. That is obvious. This, look at this. I can tell what exactly it is. It's this. It has conchoidal We're not picking out any of that stuff. We're not tearing this piece apart. So this to me, man, because we're looking for a meteorite. We don't want them all to be wrong. We want them to be a meteorite. Is this something that is worthy of looking at one step further besides the $25 amateur hour that we're doing here? If when we report back to Samuel and he sees this video, he's going to hear some encouraging things. He's going to hear not the normal negativity. He's going to hear some positive things. Which is exciting, that we're not kicking it down. What would be the next economical and most revealing scientific thing that Samuel could do with this 40-gram sample? Would it be mailing it to someone who has more experience, like myself, who can actually look at it, touch it? Does that give me any help? Or is it literally making a scientifically accurate 30 micron thin section? Like, what would you tell Samuel, if I can put you on the spot?
So it's always tricky, because whenever you have, rocks like this, there's always, if you're for sure that this has some external features that could be a meteorite, and you're very positive about where you found it, how you found it, how it looks, then I'd say there's always that, 0.01% chance it's some ungrouped achondrite, right? There's always that chance, or some kind of, sample. But at the same time, if you found the rock in a locality where basalts are fairly common, or, you found it, in a place that, generally speaking, are surrounded by other rocks that, are similar to this, then I'd say it's probably not worth it. But if you're really invested, I mean, the best thing you could always do is just have a thin section made of just a small piece, like a 1 gram, that you can, remove from there, and then just take a look at it and try to see if there's other features you could find. That'd be my guess.
I appreciate that, because the challenge, the struggle that we get in sometimes, and the greater we, is the collector has this piece. Like, this was literally, as the story goes, a witnessed fall that his father landed 5 feet from his father picked up, and now it's his. I don't know if it's been in the family for 5 months or 50 years, but I hear all kinds of different and varied histories of rocks.
Can we see the in situ picture just in the meantime? Because Daniel makes a good point about other rocks in the area. And I thought I saw like 3 really huge basalt rocks around the bottom of that broken tree.
Yeah.
Yeah. So I
Hey,
guess,
can I add one thing too? I
yeah.
could be wrong, but I believe near the beginning of the video, he said something about a date. So I don't think it's been years. I think it was fairly recently.
Okay.
And
Thank
so,
you.
yeah, and one thing,
Now,
I mean, in case we don't have time to like send him a separate message, I do want to add that if this is, let's just say it's a chondrite, is it worth spending the hundreds of dollars to find out if it's meteorite? Because it's not going to sell for hundreds of dollars.
No,
yeah.
but then you would know.
Yeah, I think that is, well, if you look at it, a classification is going to cost you several hundreds, starting around 400. A thin section will cost you less than 100. So it really depends, as Daniel said, like how invested are you in it? If you can't complete your mortal life without knowing the answer, then spend $100, get a thin section, get it analyzed, and that'll give you so much more information. But also, Sue is exactly right. If you're looking at this for a monetary payout, it's really not there. But the coolness of finding a meteorite, witnessing a meteorite, and having that story validated by science is priceless, in my opinion. So,
We just
I
don't
agree.
know what motivated Samuel to send it in. Like,
Yeah.
is he trying to find out for himself or his dad, or was it like, oh, it's only $25, let me see.
Yeah.
People in our group would definitely want to spend the money because they are absolutely in love and obsessed with meteorites, but we don't know if Samuel feels the same way.
Right. And another point for science would be, is this just, could this be another meteorite to this location? Which I'm not familiar with how many meteorites are found there, but that could be neat, So, yeah, it doesn't just jump out at me as meteorite, but Daniel's right. It could be exceptional. It could be a breccia. Breccia is something that definitely jumped to my mind but earth breccia, but yeah. Might be worth, like you said, too, Topher, just having one of us have it in hand and look at it too.
To
I
answer
appreciate
Allison's
it.
her question or what she had mentioned, I do not see any approved and published meteorites for the entire country of Nicaragua in the Met Ball.
Okay.
This would be the very first meteorite found in that country.
All right. We are going fat on this one. And when I think about fat, I think about Boris. No, Boris is on the crew now. No, I can make fun of you. Boris, what do you have, man? You raise your hand.
Yeah, no, I would, I think, first of all, I just echo everyone's comments. Great video, really good description,
Yeah.
very thoughtful description. So, hats off. I agree, Topher. I think you made the comment. It looks like a weathering feature at the outside. It doesn't look like a crust. It's more of a weathering patina. I would suggest just taking it to the local university. A lot of these guys that at the universities, they're familiar, they're local geologists. They really understand, what to expect in that area, and that you're probably going to get sort of a real time, very honest answer, and it's probably going to be right off the bat. So, and a lot of these people at the universities, they're very receptive and open to walk-ins from the public and interaction and exchange. And the other thing, just as an observation, I agree, it doesn't look very meteoritic to me. It does look sort of basaltic. I mean, land of volcanoes, right? So that's what you would expect. And the other thing is the when you look at inside, all of the clasts, they're not rounded. They're very kind of angular, rough, poorly sorted. There's a texture to that. It could be a very rapidly cooling basaltic rock. It could also be a highly compressed or condensed pyroclastic flow with a lot of ejecta material that's very angular and poorly sorted, and then just compressed into a rock. There's a number of things it can be, kind of igneous rocks, but it doesn't look to me like it's from out there.
Awesome. I appreciate your feedback. You sound extremely intelligent, so you've got me fooled. No, good job. Could you do me a favor, because you are unofficially and now a member of the crew? Boris, how do you know that? What do you base that on? What do you do? Who are you?
Professionally, I'm a geologist, a sedimentary geologist, so I'm not a hard rock or a geologist or an igneous geologist, but you know, going back to a previous life, I did take all of those courses, and I trained in Canada, mainly again in sedimentary regimes, but you know, we've had the usual metamorphic, igneous, petrography, crystallography courses, and so when I look at a rock like this, it may not be my focus area of study, but there are textural aspects, sort of visual aspects of this rock that do suggest perhaps what it's not more than what it is.
That's amazing. Welcome to the crew. Thank you
Thank you.
for going through your, not that you have to do your qualifications, but it really gives your opinion and your feedback some weight to it. The crew is strong. That's all I'm going to say. The crew is strong. I am trying to move on to the next sample, but we have two hands up. We have Sue Spinato. Go for it.
I'll make it really quick. I just want to remind people that, that are looking for meteorites. A lot of people mention, I think Samuel mentioned in his video, the similarities between what he sees as meteorites, like online or through study, and his rock. Try to look for the differences. I think that will get you a much quicker answer, because when you look for similarities, you kind of tend to not notice the glaring differences. So look for the differences between your rock and established meteorites first.
Exactly. Thank you. I'm going to say, do that with this exact frame right here. I'm hoping this is a natural wear or a natural break, or just naturally that you didn't rub it with sandpaper. But when you go to a legitimate meteorite place where you can see legitimate meteorite pictures, look for edges of fusion crust and only focus on that. Throw everything else out, only focus on the edge of fusion crust where it meets what it's meeting. And then after you look at 100 of those pictures, pull yours out. Is it the same? Thank you guys very much. Pat, I'm going to leave your hand hanging. No, I'm not. What's up, man? I would never do that, Pat.
So, it's a tough act to follow, a meteoriticist and a geologist, but I'll give it my best. So this one, first thing we look for are features inside. This does have features inside, but they're not chondrules. There's nothing spherical. There's no layered structure. The little angular bits appear to be very internally consistent, and we're looking at this on the millimeter, 2 millimeter sort of scale. So I think these probably are very small crystals and perhaps fractured crystals. So, but they're not chondrites. And this thing, or not chondrules, this thing doesn't look like a fresh fall at all. There is some black, but it's very patchy and it's very worn. There is the white material there, which we call caliche, and usually it's some sort of lime deposit. That indicates it's been on Earth for a while. The hot when found is a big sign. Meteorites generally, super fresh falls are cold inside because they've been out in space. This does have some very small vesicles. So, if this were a meteorite, it's a super weird one. It's one of those pesky achondrite. It might be one of those pesky achondrites. And the Earth is made out of the same thing that the achondrite meteorites are. Earth is a differentiated parent body. So, and also kind of the overall spherical shape, not a normal shape we see in meteorites. So I'm going to say not a meteorite for those specified reasons. And the crew is super strong. We've got an excellent showing today. Thank you.
Thank you, man. I can't believe I'm going to ask another question about this rock, but the conversation is good and the crew is strong. So I'm going to play devil's advocate on Samuel's behalf right now. Are you kidding me? Those are obvious CAIs. You guys show them every week. Look at those things. That's exactly that Professor Pat. Oh my God. Every week he's going on about these CAIs, about how cool they are. Custer chondrule, man. Like,
yes.
Don't they look like they could be in some, I'm not asking you, Pat.
Okay.
Does anyone have an opinion about, I'm asking Daniel, I'll just point you out. The likelihood of this being a meteorite that you are talking about, the types of meteorite you're talking about, the melt breccia and CAIs, would you find those together?
Well, Topher, if you're taking a approach from Samuel's point of view and pointing that out, the first thing we have to do is, rather than ruling out what it is, we have to rule out what it can't be. So we have to think about what meteorite groups, if those were CAIs, we have to think about what meteorite groups have that, first of all, CAIs of that size. So we'd have to know what size they are relative to everything else, and then the abundance. And so as we can see, if those were CAIs and if we assumed everything around it, those grains were actually chondrules. If we made the assumption there, first of all, the fact that the CAIs are much larger than the chondrules isn't really something you see in most carbonaceous chondrite groups. When you look at CV chondrites, yeah, the CAIs may be a few millimeters larger, but they're not an order of magnitude larger than the chondrules. So that's the first thing. And then seeing them in sort of that sort of texture, when we look at CV chondrites, most of them, of course, are brecciated to some extent, but we don't see that many, not saying that they exist, but we don't see that many CV melt breccias. That's sort of the first thing. So if we are to put together the fact that this looks like it has sort of an igneous texture, might be a melt breccia, but yet has CAIs, we're already getting in that sort of region, and that don't even fit sort of the primary qualifications of most CVs or CKs, then we're starting to get into that territory where it's more than likely not what you'd expect it to be. So I would say that if this was a very rare chondrite, brecciated with a bunch of melt, and somehow you have large CAIs and very small chondrules, well, then the only thing, of course, would be this would be some kind of ungrouped, carbonaceous chondrite. But the odds of that versus this being a terrestrial rock are way lower than that. So
thank you very much. Yeah, that was perfect. That was exactly, yeah. I don't know if I prompted the AI once in my life for the first time, I got something right. No, that was fantastic, because we always like to look at what are we seeing, and if it is that, could it be with this? We are going on to, so I appreciate everyone on the crew. That was we dissected that one, a 35-minute single rock ID. Good night, everyone. No, we have one more. I feel bad for Ren, number 2. Who does number 2 work for? I got to put that in every time. Ren submitted this one, and guess what, guys? It's from my backyard, from Arizona. So it's found in the, well, I don't want to say in the desert. It was found on top of the dirt, but Arizona is a desert, so highly magnetic. Its streak test produced red and gray. So tested negative for nickel, and we recently had discussion about how sensitive those tests are. So Ren reports that it did not etch. So that means that they attempted an etch, but the sample did not take an etch. Irregular and angular shape, possible regmaglyphs, and maybe some thermal crusts.
Hey guys, I found this rock in the Arizona desert earlier this year. It was sitting on top of the ground and not too far from a suspicious looking hole in the dirt that was about 18 inches deep. It weighs 1,763 grams. It has a density of roughly 3.0 grams per centimeter cubed and is slightly magnetic. On this side, I see what I think are regmaglyphs in the middle here, and possibly some flow lines on that bottom right side. There are visible exterior fractures starting at one end and extending to the other. The 2 cuts off the rear section reveal a gray-black interior with some flecks of white, gray, and black. Throughout the matrix there are many fine fracture lines. On the exterior there are some patches of white. Here's some close-ups of that, and a full 360-degree view. Thanks for checking out my rock.
That was phenomenal. I think that the submitter used an AI-generated voice, put that in, and had that done for them. So any submitter, if you are apprehensive to record your voice, you can always send it in a Word document or do what Ren did with an AI-generated voice.
We can have what that one guy did and talk like a Hannibal Lecter.
Yeah. We are getting some really good looks at the samples today. We're getting some good hands up as well. But yeah, we get light box, we got lighting, we got good narration. Dave Pinsky, you want to take the lead on this one?
Yeah, a couple points. One, he said there were flow lines, but there's no fusion crust. Usually you see
Yes.
flow lines on fusion crust. Second, the interior really gave it away because there's almost no grain to it at all. And meteorites have some sort of grain.
Hey guys,
Unless, yeah,
from
so that's pretty much the two big points. I didn't really go anything after I saw the fact that there's no grain. So that's
All
what I
right.
got.
Dave, thank you. Allison?
I do see some stuff on the outside that I didn't necessarily love to see, and there was like a blue teal kind of color. The interior was quite homogeneous, and there's quite a bit of like little hole textures, like little pock marks and stuff that don't really look like regmaglyphs to me. I'm with Dave that the outside, if we're seeing flow lines, we should see fusion crust as well. So I think it's gonna be after this, just a bit, just a smidge bit. Right after that, we could see it in the right-hand corner just a little bit. Okay, there's one top screen, that little shiny guy there.
That right there?
Geologists in the house, does that look like a little piece of hornblende to you? And would that maybe be why we've got a magnetic attraction? Anyway, my ultimate thought there was that I do think I'm seeing just a little bit of hornblende in there, which would cause this stone to stick to a magnet. And we'll have to have some of our smarter guys follow up on that for me.
Fantastic.
Thanks, Topher.
Allison, we got love for you. Thank you every week. Pat.
Yeah, so I'm afraid this one is not a meteorite. The picture of the interior shows a black, basically featureless.
That's my picture. Sorry.
Yeah, as soon as I went away from you, I knew I pulled it up. Sorry.
No worries. So, we've got a black, basically featureless interior. We can see some small crystals. We see nothing that looks even close to being a chondrule. And the outside of this rock is not a fusion crust, it's a weathering rind. And many of the basalts in the Western United States will attract a strong magnet. So, and
Yes.
it does show some cracks through the inside. And those are very consistent with a cobble bouncing down a river and hitting other larger rocks. So my conclusion is this is not a meteorite, it's a piece of basalt. So this is something I wrote up just a bit earlier this morning, that density doesn't prove it's a meteorite, but it can rule out whether it's a meteorite. It gives us another piece of information. In 95% of the cases, meteorites have higher densities than Earth rocks due to their higher iron content. And then finally, I just threw in the one that if an object appears to be metallic, and this one doesn't have a metal luster, but if an object appears to be metallic and doesn't attract a magnet, it's not a meteorite.
Bingo, Pat. Where are the metal blebs? What is causing the magnetic attraction? We should see what's causing that magnetic attraction, and we just don't. Thank you.
So one of the minerals in this thing has some amount of iron in it, and it's enough that it'll attract a strong neodymium magnet. So these are densities for ordinary chondrites and other sorts of chondrites, and we're seeing that the averages are in the 3.2, 3.3, 3.4 gram range for ordinary chondrites, but this really doesn't even classify as a chondrite because we don't see chondrules. In the years of Meteorite or MeteorWRONG page on Facebook, probably the third or fourth most common MeteorWRONG are pieces of basalt. And they oftentimes have a pretty rounded sort of shape, which could look like soft shoulders on a meteorite, also look like river cobble wear bouncing down the river. And I think it's one of the last slides here shows densities of some common MeteorWRONGs. including basalts, which are in the 2.9 to 3.0 gram per cc. And the finder of this rock did give us a density of 3.0 grams per cc.
I appreciate it. Wow, this time cleaning up better is Daniel Sheikh.
Well, thanks so much, Topher. So I had a few comments when I initially saw the thing. The first thing I noticed was they mentioned something about a potential red streak. They said red or grayish streak. And then when I saw the image, I was initially thinking, perhaps if this was a meteorong, you can always throw in stuff like hematite. But based off of its specific gravity or its density, hematite's a lot higher. It's, I think, about 5 grams per cubic centimeter. This one's about 3, which, as Pat mentioned, is in the range for basalts. And from the images I saw, it had a very fine-grained texture. I was looking at, I think, some of the images toward the end of the video that showed individual crystals, I think, in there.
Yeah.
And some of those looked
Hey,
like
guys.
some of the opaque phases you tend to find in terrestrial basalts, like right there, that sort of reddish color, it kind of stands out. I mean, just by looking at it from the relief of it, you can make the case that this could be either some kind of what we call a phenocryst. If this was an igneous rock, again, with maybe a porphyritic texture, it's a little larger than other stuff. Could be a pyroxene. There's also the chance this could be some accessory phase, like in basalts, you can find things like, ilmenites, you can find rutile. That's something you can find as well, which may be a little bit magnetic, not really too much. So yeah, I would probably say some very fine-grained igneous rock, and it doesn't really appear to have a fusion crust. So I'd probably say most likely terrestrial, if that was the case. Yeah.
I appreciate your feedback and your opinion. The crew hit it out of the park again today with some great feedback. I'm going to focus this on this picture right here for myself. I don't, as we said, we don't see any chondrules, don't see any metal flakes. It's nice to see that the rock is not the same on the inside and the out, because we always tell people to look for that. So that's one good thing. The overall shape of it was pretty good as well. Little too monotone on the outside, too fine grained. There was no difference in it whatsoever. It looked like homogeneous through on the entire outside, and that was borne out when you cut it open and look on the inside. It is homogeneous. It is one throughout, and that was displayed on the outside as well. So, crew, thank you very much, and Patreons, thank you very much for your time. I super appreciate it, and we're rooting for you guys. Show us your wrong, show us your rights. Thanks a lot. Have a great week.